So until now we've added and subtracted from our x and y values to shift our functions. Now we're going to look at multiplication. And first again we're looking at the y values, and then second we will be looking at the x values. So we're starting by simply multiplying our function values, our y values, by 2. So our transformation is y equals 2f of x. That means simply our y value gets multiplied by 2. So we could do that again just simply graphically by taking each point and multiplying the y value by 2. So our first y value is 4, so it becomes 8. And then our next y value is 12, so it becomes 24. And the next one is 7, so it becomes 14. And then the last 2 points in the same way. 13 becomes 26 and 9 becomes 18. Now as you can see now, the whole function has kind of stretched vertically. And so that is what happens when we multiply by a number. For now we still want to fill in our table and then check our values, and then also think about what does that actually mean. So let's start by again making our usual points, because that's always where you want to start, by selecting certain points. So we'll keep doing that. And just like we did when we did it graphically, we leave the x unchanged and we multiply the y value simply by 2. So we can then say that our function has stretched by a factor of 2, and so our carbon dioxide values have all doubled all across the board. Now from here we can ask the question, well, what happens if the number is smaller, for instance? So let's take a look at what happens then. We are investigating 1/4 times f of x. That means every value of y gets divided by 4. So it's the same, 1/4 times f of x is the same as f of x divided by 4. So let's again, this time around I start with our table. So I'm starting again by making my points. And now I divide each y value by 4. So I get negative 15 and 1. So the first two will be easy, and then the other one we get fractions, or since we want to graph them, decimals would be a better way to go. So now that we have our values, we can graph our points, and many of the points will now be very roughly estimated. So now that we have our values again, we can connect them. As you can see, our graph did not end up perfectly aligning all the points. That's simply because it's too hard to estimate in the way we have the scale. But it is clear that it's the same graph, just divided by 4, so compressed by 4. So our function has been vertically compressed by a factor of 1/4, and therefore all our carbon dioxide values have been divided by 4. So to recap one more time, to see when are we stretching, when are we compressing, in the y direction, in the vertical direction, if the number a by which we multiply our function value, our y value, is greater than 1, then our original function will get stretched by that factor of a. And if we have a factor of a between 0 and 1, so less than 1 but greater than 0, then our graph compresses vertically. And you might ask, well, what happens if a is negative? We will get to that later on and look directly at what happens when a is negative.